Hello and welcome. Today I'm going to be talking about a few basic Linux commands that you're probably going to need to know for CS322. However, it's usually a good habit to get into to be able to both work out of the terminal and just be familiar with basic Linux commands because these do not just stop at Linux. They're usually applicable to any Unix-based operating system, which means whether you're on any Linux distribution or Mac OS, you will find that most of these commands are either applicable or you can install them relatively easily. So again, this does not stop at Linux. These are a lot of these are also applicable to Mac as well. And Windows users, of course, I've already recommended using WSL, Windows subsystems. I believe that's what it stands for. I'm actually not sure. Uh, but you're probably going to want to do that. And I'm sharing my screen from a Mac, but I'm connected to a Linux server through Secure Shell or SSH, which is something that I probably will talk about in another video. And you can do that as well to connect to either department servers or in the future, any server that you might be working from. And again, this is another scenario you might find yourselves in that the work you're trying to do is going to be done on a server or a computer that's somewhere else that is not your local computer. And it's something that I personally do very frequently. I rarely work outside of my own computer. And again, there's other tricks that you can do to be able to do that. Like with version control, for instance, you can write code locally on your computer, and then with every change you make, you are going to have to push that change. And then you log onto the server via Secure Shell, usually, and pull those changes. But it's usually an inefficient circle. Um, Another option you may have is some IDEs like VS Code allow installing an extension on remote, remote servers, and you can just use that to get into that terminal. But again, it's something that I personally don't prefer because I've gotten used to working out of the terminal and I'm actually more productive that way. Anyway, you will find the commands that we're going to go over in this video useful if this is your first time working with Linux or if you just don't have a lot of experience working with Linux. So first of all, I've wiped everything clean to make sure that you will get almost the same experience if you're on a Mac and using your terminal for arguably one of the first times, or if you're on Linux, or if you're on Windows using WSL. So I'm actually logged onto an Ubuntu server right now, and that's actually the first command I'm going to go over is the command uname. I'm just going to type that in, and of course it tells me Linux. There's also uname -m, which is going to show you the architecture. Uname-A is going to give you a more detailed view of your operating system, the host name, and we can also see that I'm basically on Ubuntu. So that's just the first command that we're going to learn about. But the second one is navigation. First off, I want to know where I am on this file system. And the command that you would normally use is pwd, and it tells you what directory you're in. And currently, I'm in my home directory. Now, usually on Linux machines, the default is that user home directories. Everybody has a home directory. If you're on Mac, this would be /users/your username. If you're on Windows, it would probably be whatever partition it is, C slash I don't know if it's still this way, but there's a subdirectory called users and then your username. So every user has a home directory where all of their files are basically. And if you have a graphical interface and you have a desktop, a documents directory, anything like that, they will all show up here basically. Um, and another thing you might find useful is just getting to know what your username is. And you can always type in who am I, and it will give you your username. every user has a unique identifier, and you can get that by typing in ID. So it's basically telling me that my user ID is 21406. And you can also and you also have a group ID. So every user comes with a group that's just them. And the standard practice for that is you just assign the same UID and GID. So both my uh, user name and my group name are the same thing, and so are their IDs. It's just standard practice. I'm also part of other groups. In addition, I'm part of the Docker group, and groups are there just to handle permissions and in terms of who's able to access specific resources or specific files. So that's kind of the point of users, and I'm part of. I'm actually just part of multiple groups on this particular server. Another command that you might find useful when your terminal is getting too cluttered is the command clear, which should wipe everything clean. Um, so these are some basic commands that you might find useful. I also want to talk about different types of shell. Shell is the program that you're running all of these commands through. And there's not only different versions, there's different shell programs. And historically speaking, one of the original ones is Born Shell or sh. So that's going to be /bin/sh. I'm actually going to confirm whether it exists or not. Yes, it does, and I'll talk about what ls does in a little bit. But there's also as of right now, the standard shell that you might see in certain Linux operating systems. I'm unsure about Mac whether it's Bash or just shell. Um, the one that's more frequently used is Bash, and it's the one I'm currently in right now. Um, and it stands for Born Again shell, basically. It's just as far as I know, it's an improved version over your standard shell. Comes with more features, and you will also find that you use the same type of program to write scripts in Linux to write shell or Bash scripts that you would just put certain commands in, commands you would normally type. So if you find that you're trying to do something that's comprised of multiple different commands that you type in your terminal in Bash, you can just put those commands in a file. You can add variables to it. You can add conditions and for loops and so on to it, and it will really help with automation, basically. And it's something that's frequently done in large software projects, is that things that get too complicated turn into scripts that you get to call, so you don't have to remember what command and what arguments to use every time. I personally use C Shell, which has a lot more features compared to Bash. It's more extensible. You can just add plugins to it, and I don't know, the easiest way to put it is make your terminal pretty and add more colors, and I don't know, get features that might help your productivity. And I don't know if I'll have the time for that, but I will try to post another video on Z Shell and my terminal setup. It's very different from what you're seeing right now. So it's not as uh, I don't know. It's not as early 90s as you're seeing right now, even though this is technically, I think even not early 90s, it's closer to late 90s. But anyways, so I'm using Bash right now. I'm in Bash. Um, and I just felt the need to clarify these. Another thing I want to quickly point out is the file system structure in Linux. If you're not familiar with it, uh, you should probably know the difference between relative and absolute paths while we're still talking about navigation. I'm first going to go over the command ls, which lists all the files in the target directory, and by default, it's the current directory. So if I ls, I can see that there are no files in the current directory, except that's not entirely true. ls skips hidden files, and in Unix-based operating systems, any file that starts with a period, as in it has no name and it's only an extension technically, those are called dot files or hidden files, and ls by default doesn't show you those. So to get those, you need to type in -a to get all of your hidden files. And you can see I have some hidden files in here are already that I don't see, and some of these are related to some of these are related to the programs that pretty much all of these are related to the programs that you use on this operating system. So Bash history is going to keep a fixed length of the history of commands that you use. That's how you can press arrow up and get the previous command. So that's what Bash history is there for. It's just going to keep a history of commands that you've typed. Bash logout is a set of commands that are going to be executed when you log out or you terminate a Bash session, because I'm in a program right now and that program is Bash. So once I start the program Bash, the commands in Bash RC are going to be executed. It's just things that set up everything for me, because there's a lot that goes into just setting everything up for myself. And the advantage of that is if there are certain variables you'd like to set, if there are certain programs that you would want to load, or if there are certain aliases or functions that you want to define that get something specific done for you, you can put those in Bash RC. And you will have that variable or that function or that program every time you open a new Bash session. And bash logout does somewhat the opposite. It just prepares to quit the program. Um, there's hist file, which actually you probably wouldn't find this. It's just something customized for me that I forgot to get rid of. But then there's things like your dot local directory, which I'll explain in a bit. It's kind of all of the local programs that you install just for your user. Um, there's .ssh, which will hold everything related to SSH. That is SSH keys. That is your just configuration for whenever you use anything related to SSH or secure shell. And the things that you might find yourselves using in this class is one, setting up SSH keys to access Git or your Git repository or things related to that, basically just for your GitHub. And another that you might find is setting up keys to, SSH into a server, like I'm doing right now. So that's kind of the purpose of that. But beyond that, I don't think there's much else that we need to go over. Cache is usually the directory that your local programs try to cache files that they download frequently or create frequently in. And you can just get rid of it and you probably will still be fine, but it's always recommended to look at it before you get rid of it. There's temp, which is a temporary directory where programs can store information. Um, and yeah, those are pretty much the stuff that you need to know um, as of right now. But the point I'm trying to make is when I type in pwd, it's telling me I'm in uh, the starting from the home directory. So note that the path is starting with a forward slash. And whenever you have any path start with a forward slash, it's referred to as an absolute path, meaning you're specifying that you're starting from the root of the entire file system, and then going into the directory home, then into the directory users, and then into the directory alleh. Um, And if we want to look at what's in the root directory, instead of typing ls, which is equivalent to typing in ls period, and period means current directory, those are just equivalent. Instead of doing ls period, you can do ls slash, and it basically gives you the root of the file system, basically. And you will find directories that you probably don't want to mess around with too much if you don't have root and you don't know what you're doing, and those are the core operating system directories like bin that holds all the core programs that the operating system is going to need. And that doesn't that's not to say that the rest are necessarily extensions. It's just the basic commands that are going to be needed to load the operating system. And it's always assumed that the bin directory exists when you're booting. So it's basic commands that are required to load everything else. And then other programs go into the user directory. There's configuration files that go into etc. There's a directory called root, which will be the home directory for the user root. And root is basically just a user with all privileges, basically. And when you type in, if you're familiar with sudo commands, when you type in sudo, if you can run any command with sudo, you're effectively executing that command as the user root. But what I really want to show here is that, for instance, let's try making a directory in our home directory where we are right now. The way you would do that is type in make dir, and then let's call it something. For instance, I want to set up a directory for CS322, so I'm going to type in make dir CS322, and if I ls now, I will see that I only have one directory named CS322. And I can even look inside the directory by typing in not an absolute path. I could type in an absolute path, and then 322, and then of course it's empty. If it doesn't exist, it's going to give me an error, of course. But I can also type in a relative path, which means I know that this directory that I'm trying to look inside of is in my current directory. So I can give it a relative path from here. So I just type in 322 works set, whereas if it doesn't exist, it will give me an error. So this is just the difference between relative and absolute paths. And one thing in particular that you need to keep in mind is whenever you're writing any script or dealing with paths, um, if you're if you're using relative paths, you should be careful because someone might execute your script from a different directory. So always be careful when you're using relative paths over absolute paths. And just in general, be careful because if you do it wrong, you might just get you will get unexpected results. You could, if you have root privileges, you can accidentally delete the entire file system by just removing everything under /. And you, if no process on the operating system stops you, then you will end up just breaking the OS. Um, so these are just this is just a soft uh, introduction into the file system and paths. Other commands that you can use to create files or directories. One other command is touch, which just creates an empty file. I'm going to create a file called, I don't know, 322 slash readme dot markdown. And now if I ls into 322, and before I type in the 22, press tab and it will try to auto-complete. Again, something that you can do with most setups. You don't even need an extension for that. And if I do that, I will see that I have a file under 322 called readme.md. And and now let's try to remove a directory. And the command for removing a directory is rmdir, unlike makedir. So if I try to remove this directory, it will give me an error because the directory is not empty. And it doesn't matter whether the file in there is hidden or not, as long as there's files in there, it won't let you delete it. And it's usually a good failsafe when you want to get rid of directories that are empty that you don't need. So it will fail if you're trying to remove a directory that's not empty. If you want to remove files, you would just use the command rm. So I can use rm 322 and then readme and remove it. And then I can try rmdir 322. However, that's not the only way to do this. I'll make 322 again, and I'll touch 322 slash readme again. And the alternative to that is rm-r, which stands for recursive. So I can recursively remove 322, which means delete all the files underneath it, and recursively all the directories underneath it, and then just move back up and try to remove everything. So rm-r is the way you would want to remove an entire directory, regardless of the files underneath it. You just want to delete everything. And if I look at my directory now, there no longer is a 322. I can actually run this again, so it would fail. Um, Sometimes you will find that depending on the permissions set for files, permissions are something that I'm not necessarily going to get into in this video. Uh, you can look at online resources for that, to be honest. But sometimes you might not have, depending on the permissions or what's going on with the files, the rm command will prompt you for individual files that you would want to delete. It just asks you to confirm. And the way to get around that is to add an F flag, stands for forcibly remove, which won't prompt you for that. The only case where rm-rf would fail is if you don't have the necessary permissions to remove that directory. For instance, if you're trying to remove somebody else's directory, or a directory owned by somebody else. So that's the only instance this would fail. However, just be careful with this command, and just understand that it's technically more powerful, so just use it sparingly. Uh, One more thing that I forgot to mention is actually create the directory 322. How do we change directories? We've been stuck in our home directory this whole time, and it's not really efficient to use relative or absolute paths everywhere. So you can use the change directory or cd command to jump into a directory. And now notice that the bash prefix that's going on here is telling me I'm in the 322 directory. And the tilde is just an alias for your home directory. So if you want to look inside your home directory, you can always type in, I'm actually going to type in the -a because I want hidden files. So you can always use either tilde, you can use the absolute tab, you can use the home environment variable. There's always going to be the variable home that you can look at, or I'm actually going to ls-a here, and you can see this directory is empty, but the things that ls is returning is period, meaning itself. You will always have that in every directory. And then two periods means parent directory. So I can ls my parent directory instead of myself, and it'll still be home because I'm in home/322. So this is another thing to keep in mind for relative paths, is that you can start it with period slash or period slash, and just to make it clear, period slash is not equal to period slash, and neither of them are equal to just slash. Just pay great attention to what paths are starting with, because that determines a lot. Let's go back to creating a new file. I'll just use touch readme.md. And if I look at this directory, I have that file in here. If I want to copy this file somewhere, I can use the cp command. So cp readme.md, and I'll specify my parent directory because let's say I want to create a copy of readme in the parent directory that is home. Now, if I ls parent, you will see that I not only have the 322 directory, but I also have the readme.md directory. So these are just basic stuff. You also have a move command. And the move command is what you would use to rename files. So if I wanted to rename readme to, I don't know, some file.md, I would just use the move command. One thing to keep in mind is that just you be careful with move, because it technically copies and then deletes the source. And when you're using it on directories and the target is a directory that you're replacing, just be careful with it, because depending on the way you've set things up, it might merge or completely replace the directory you're targeting. So be a little bit careful with move when you're applying it to a directory, especially when you're moving it to a target location that already contains a directory with that name. And of course, one command that you would also need to use the -r, the recursive flag for, is copy. You don't need it for move, but you need it for copy. So if I want to go back to my home directory and move 322 to 322-A, I have no problem doing that. But if I want to copy 322-A into 322, it's just going to skip over that because I'm not saying copy recursively. But if I specify that flag, then it's all good. Before moving on to the next few commands, I just want to note that all of the commands I'm typing, ls, mv, cp, all of these are essentially programs that I'm executing, and they're in an environment variable. You can think of it as a global variable that gets initialized every time I log into Bash or any other shell. So these are environment variables that your operating system typically initializes for you, and you can even modify. And one of those is the path environment variable. And I might have already I haven't talked about the echo command. It's essentially printing something out. So I can use echo to print, for instance, home that we already talked about. It's going to give me the path to my home directory. There's also the user environment variable, which is going to give my username on this system. There's also path. And so this is basically giving me a bunch of directories separated by a colon. And it starts out with, these are preset by the OS, but the most important of which is /bin that we already talked about, holds the basic core OS programs that it needs to even boot. There's also /sbin, there's /userbin, which are the programs that are system-wide programs that come with the operating system. There's /user/local/bin, which are all the programs that do not come with the operating system but are installed at the operating system level. Things that you end up installing through apt or snap or whatever package management system you have. So /user/local, that's basically going to hold all the programs that you've installed after you install the operating system. And one thing to note is that /bin is just a directory that it stands for binary. It's just a directory that holds the binary files. So they're not all necessarily going to be binary files. Some of them might be bash scripts, but it's essentially a directory of executables. There's other directories that are going to hold files like, I don't know, C or C++ header files, libraries that are built that are not directly executable. There's a share directory under like /user/local and under /user, which is going to hold miscellaneous files like documentation and manuals and such. And the reason why I brought this up is that as long as the operating system you're on has the man command, so if I type in man ls, unfortunately this OS doesn't have man installed, but basically man, which stands for manual, takes in any command and tries to locate its manual or man page. And it's basically a clear text file that is going to display to you as the manual to that program. So it tells you how to use that program. But if you don't have man installed, programs usually also come with either -h or -help. And that's basically just going to print out an entire, it's almost the same as the man page. But again, some programs might not have a designated help file. But usually what -help gives you is just instructions on how to use this command, what arguments you're allowed to pass, and whether or not the arguments themselves are flags, meaning I can just type in ls-a, that's a flag, meaning I'm just toggling something, it's a Boolean, or whether it's an argument, meaning I type in like, I don't know, I type in a name, a key, and give it a value. For instance, color is one of those. It's basically an argument and not a flag, because once you type in --color, you have to give it another argument. or format. You need to give it an argument. You can't just type in minus minus format and be done with it. Um, so it basically just gives you instructions, and some of them are a little harder to read, some of them not so much, but eventually this should be your primary source of information, so you don't even have to, I don't know, Google the command. And one thing that I don't like myself is the fact that it prints everything out in the terminal screen that I'm in. Basically all of this is technically a file that I'm looking at. And when it prints all of this out, the problem with it is there's a limit on this file, pretty much, and that's basically up to the bash settings. Or if you're using any other shell, the shell is going to limit the number of lines it is going to keep in its register because it's not going to be infinite. So if the help file or any other program you execute has a really large output, you're going to run out of lines and you're not going to see all the output when it's done. And that's usually a bad thing. So the thing that you can do about that is piping. And piping essentially means type whenever you're done with the command you want to execute, type in the pipe character, and then what you can do is type another program that is going to take the output of the previous program um, in as its input. So there's an input stream and an output stream, and the input stream of the command I'm about to type will be the output of ls. And one of those commands is less, which is technically just a file viewer. So it's just going to try and view all of this to me without polluting my terminal screen, and then I can just quit it when I'm done with it. So I'm actually going to clear everything so it's more clear. And I already used I think I almost used the which command, which is super useful because it tells you whether or not you have the program on your OS without going through the trouble of trying it. So if I want to test whether I have less or not, I can just type in which less, which gives me the path or paths to the program. No, it will give me the path that it would call. And that's another thing, is that all of these directories that hold all these executables or these binaries, there might be some overlap, and the order in which they appear um, in your path variable determines the order that's going to replace it. So if the path is earlier, the first match is always the one that's going to come up in which, and the first one that's going to be executed. So let's actually try this. Let's do ls dash dash help, and I'm going to pipe it and pipe the standard output, not errors. It's just going to be standard output by default into the program less. And you can see it's printed out, but it hasn't scrolled me all the way down, and it's not in my terminal anymore. But the advantage here is I can scroll with my arrow keys, or I don't know if your terminal supports it uh, with your mouse scroll bar thingy, but you don't have to do that. But what I really like about the program less is that the key bindings that allow you to navigate this are similar to to Vim, the editor. And I'll talk about Vim in a little bit, but basically it means that I can not only navigate this easily, there's shortcuts like GG that lets me jump to the top, capital G that lets me, or Shift G that lets me jump to the end, to the bottom. I can search by typing in / and then the pattern I wish to search, for instance, color, and then press enter, and it'll show you the instances where color is repeated. I can type in N to go to the next instance. I can type in capital N or Shift N to go to the previous instance. And these are just very standard key bindings known as the Vim key bindings. And I'll talk about Vim, the editor, in a little bit. But this is basically the idea. And when you're done, you can just press Q and it'll exit plus. And that's basically just less as a viewer. And the next command I'm going to talk about is just Vim, the editor, because we talked about it a lot but haven't really seen it. So Vim is an extension of the standard Vi editor on old Linux operating systems, and Vim is just an improved version. And in many Linux distributions, and I also believe even in Mac, it comes standard pre-installed as the default terminal editor. So I'm just going to use Vim because I know even Vi is alias to Vim, at least on Ubuntu. So I'm just going to type in Vim and not specify a file, but you can do that. You can just specify like Vim 322 slash some file, and it'll start editing that file. But I'll just open Vim, just like normal. Uh, and Vim is really interesting because it's not just a standard file editor in a terminal. It actually has a lot of features. You can add plugins and extensions to it. You can add your own shortcuts. And eventually you can use it as a full-fledged, not just code editor, but even your development environment. So you can mess around with Vim a lot. And if you're interested in learning Vim, the best thing you can do is launch the program, which again comes standard. If you have Vim installed, you also have Vim Tutor. If you type that in, it's almost a stripped down version of Vim that is the text is enough to teach you how to use Vim. So just use that. And the first thing you need to know is how to move around. You can move around with arrow keys, but it's not recommended because you're going to have to move your hand all the way to the right side of your keyboard to get to the arrow keys. So the standard Vim key binding is using the keys H, J, K, and L to move around, which I'm going to do right now. Um, and Vim is just an amazing editor. It's my daily editor. I know it might infuriate some folks because there's like tabs versus spaces. There's always debate on Vim versus Emacs or other editors, but to each their own. I use Vim and I like Vim a lot. And again, this is not my daily terminal setup. This is just a stripped down version to the basics, so you don't get confused. But I highly recommend Vim, and I'll probably link to my dot files on GitHub, which shows what my Vim actually looks like. And you might also see it in class from time to time. But Vim is very interesting. It's very good at increasing your productivity, and it's a keyboard-based editor, meaning you won't be using your mouse for anything. You can just do everything through your keyboard, and when it's time to type, you will get into insert mode. And insert mode basically allows you to um, it allows you to type normally without hitting all the shortcuts. And the way to quit Vim and Vim Tutor is by typing colon. Colon lets you type in commands, and the Q command is just going to quit Vim. But let me open up Vim again, because again, Vim's a really, really interesting editor. Again, the whole idea is that it's a keyboard-based editor, and it's in the terminal, so you can install them on pretty much any Linux distribution or any Unix-like OS. And on Windows, again, you have WSL. So Vim's really interesting, and let's try to edit one of those files we created. So I'll type in the command X stands for Explore, which opens a file explorer for me. Again, I use an alternative in my setup, but for now, let's just focus on this. And again, another good thing with the Explorer is that it has the same key bindings as the editor itself, so I can just move around and open up some file. And now I've opened this file, some file, and I want to type stuff in, but I'm in normal mode right now, so I'll have to press the key I to get into insert mode and start typing. So I'll just start typing intro to software engineering. This class is intended. This file is for 322 students. And pressing escape quits insert mode. And now we're back to just moving around with all these keys. And there's a lot of interesting features in Vim that allow you to completely work with your keyboard. For instance, if I want to copy this line, I can just use visual line to select multiple lines and then yank with Y to paste it. I can just paste as many instances. I can insert one character 100 times by just typing in 100 I and then the character, and it'll type it for me 100 times once I quit insert mode. I can do things like visual blocks. I can move around word by word or character by character if I choose to. Again, all of these are shortcuts that once you start using Vim and using Vim Tutor, you will get adjusted to pretty quickly. I can delete them. I can go to the end of the line. I can paste them. Um, the sky's the limit, as they say. So I can find and replace stuff very easily. I can undo, redo. Um, there's it, in my experience, and maybe I'm a little bit old school, but I don't miss IDEs and graphical interfaces when I'm working with them. I'm actually more productive than I've ever been. So if that floats your boat, feel free to go ahead and spend some time and learn how to use Vim because it will be useful. If you can find the time to learn how to use it, I would recommend it if what you're primarily going to be doing is programming. But anyway, I'm going to basically just try and save this file. And a couple of options that you have is if you want to just save this file and quit, just use X, which will save the file and quit. And there is a difference between doing that and alternatives, but I'm not really going to get into that right now. The reason why I did this is I want to see the content of the file I just modified without using Vim or anything else. I just want to print it out in my terminal, and the command you would use for that is cat. So I can use cat 322 slash some file, and it'll just print out the contents of that file. You can pipe the output of this into a command called head, which will show the first few lines of the input you're giving it. So I can just do dash n the first two lines. I believe head also allows you to um, just specify a file name. I'm not sure if it does. Yes, so you don't actually have to pipe it in. Some programs, again, depends on the program. You can just look at head help to see whether it does or not. Some programs also take in files that they read as their standard input. Otherwise, you would probably have to use cat to pipe it in. Um, and I think that pretty much covers the basic commands that you would need to know. I've already shown the get commands in class, but these are pretty much the basic commands that you need to know to get started with working from the terminal from a Linux terminal. And I'll do another video on setting up SSH keys and how SSH keys work basically, and how to use them to log into to authenticate yourself both with Git and with remote servers you're trying to connect to.